Welcome back, students, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 6, hydrated and anhydrous crystals. So, the first thing we are going to do, task number 1, is that we are going to make a copy of the lab report template. You're going to find this lab report template on Brightspace. You can either download the copy and edit it, or you can make a copy on Google Docs and edit it as we are going. So the first thing we want to do is that put your name at the top and the date in which you complete the lab for experiment number 6. Let's talk about the equipments and function. So if you look on your lab, you're going to find this table. Let's put the names of the equipments on the left and the function of the equipments on the right side. Now the first thing we are going to be using in this experiment is the beaker. The function of the beaker is that a beaker is a common lab container used to hold, mix, and heat liquids during experiments. So you want to pause the video, write down the equipment, and also write down the function. Another equipment that we'll be using is the scopula. The function of the scopula is that it is used in the chemistry lab to transfer or scoop small amounts of solid chemicals. We'll be using the scopula in this lab in order to scoop up the hydrate into the beaker. The next equipment is the beaker tongs. Now, when the beaker, we're also going to be using the hot plate. The beaker is going to be very hot, so we don't want to reach in with our bare hands to move the beaker. So we'll be using the beaker tongs. So the function of the beaker tongs is to safely handle hot beakers and move them on and off the heat source. We also will be using the wire gauze. So the wire gauze provides a stable and heat diffusing surface for beakers on the hot plate. Also be using the wire gauze. And last but not least, we'll be using the hot plate in order to heat up our hydrate. So this heats the hydrated salt, and this causes the water to be driven off from the hydrate. Now, what is the objective of this lab? So go back and we want you to write one objective you can write is that the objective of today's lab is to observe and understand the differences between hydrated and anhydrous crystals by heating hydrated salts to remove water of crystallization and analyzing the physical and chemical changes that occur during the dehydration process. Again, the objective of today's lab is to observe and understand the differences between hydrated and anhydrous crystals by heating hydrated salts to remove water of crystallization and analyzing the physical and chemical changes that occur during the dehydration process. Again, pause the video and make sure to write that as your objective. Let's talk about the theory behind today's lab, ions and salts. So, what are ions? Ions are atoms that have gained a charge. So, these are atoms with either an overall positive charge or an overall negative charge. If our atom gets positively charged, we are going to call it a cation. And if our atom becomes negatively charged, we are going to call it an anion. Now, ions, again, atoms that have a charge, could either be monatomic. Monatomic means they are made up of only one atom, or they could be polyatomic. Poly means many, which means they could be composed of two or more atoms bonded together that forms an overall charge. An example of a monatomic ion is Li plus, this is lithium plus, that's a cation. F minus, fluoride ion. The magnesium cation has a plus 2 charge, and the oxide, the oxygen ion, has a negative 2 charge. Polyatomic ions, elements with compounds with more than one element that gives you an overall charge. NH4 ammonium, you got OH minus hydroxide and CO3 2 minus carbonate. So you got the cations here, and you got two anions. Now let's talk about salts. Now, when you have a cation and an anion together, you get what is called a salt. So the formulas of salt are neutral, they are charge balanced. All the positive charge from the cation in the formula is balanced by the negative charge. For example, Li plus and Br minus, when they combine, you're going to get LiBr. You have equal pluses and minuses, they cancel each other out. If you have Li plus with CO3 2 minus, notice the carbonate anion has negative 2, but lithium has only plus 1. So, in order for the uh, compound, in order for the salt to be neutral, we would have to get two lithiums. So, we have Li2 in order to balance out the negative 2 on the carbonate anions. Many of these salts, the cations are made up of metals, for example, the lithium, and then anions are composed of nonmetals, for example, the bromide anion. Now, let's talk about hydrated salts. The word hydrate means it contains water. So, in addition to cations and anions, certain salts are hydrated and they contain water in their crystal structure. Some examples of hydrated salts are when you buy new shoes, you find these little packets inside the shoes, or maybe in your jackets if you buy a new jacket. Now, these packets are hydrates. You do not want to eat them. These hydrates absorb the moisture from the shoes or the jacket. It's very important to keep your new clothes that you buy dry. So the purpose is to dry the uh, the new merch. Some examples of hydrated salts we have here: CuSO4. This is how we write the hydrated salt. CuSO4 is our compound. This is our salt without any water. We call that the anhydrous. In English class, an means not. So not hydrous, anhydrous means it does not have water. So this is the part of the formula that represents the ionic salt, ionic compound. Now, dot here does not mean we're multiplying. This actually tells us that in addition to the CuSO4, you can treat this as a plus sign. We have five H2O, five water molecules. So for every copper sulfate unit, you have five water molecules that are surrounding the CuSO4. Now, the question is, what happens if we heat up a hydrate? If you look at the picture, now we're going to notice that hydrates have beautiful colors to start with. And when we heat them up, they're going to get a completely different color. And the reason is water makes a difference into creating these beautiful colors. Now, heating can result in the removal of water, which is called dehydration. And when water is removed, as you might have guessed, the mass decreases. The mass of the salt becomes much less because you're losing mass, you're losing water. Now, sometimes the removal of water from hydrated salt can cause a color change, which is what we're going to see. And you can actually use that color change to track the progress of the chemical reaction or the progress of the dehydration. Now, if you leave this CuSO4 in air, it'll act like a sponge. It'll start absorbing the water from the atmosphere and it will turn back to the original color blue. Very interesting. And this is what we're doing today. So here is our experiment. We are going to observe what happens when a hydrated salt is heated. Today we will be using three. We'll be showing you three hydrated salts. Now you're going to go to the data sheet now, and we are going to write down our observations. We have three reactions that we're monitoring today. The first one is the cobalt 2 sulfate heptahydrate. Now, the reason why this is called heptahydrate is because we have seven water molecules. The number is seven, the prefix is hepta. The next chemical we'll be using is nickel 2 sulfate hexahydrate. So which means that we have six water molecules. Last but not least, we'll be using the copper 2 sulfate pentahydrate. And penta means we have five water molecules. So the procedure is that you are going to write down your observation for each hydrated salt before heating, and the second is you're going to obtain so we're going to show you, we're going to get beakers, scopulas, tongs, and wire gauze. Using separate clean scopula, we're going to add a small quantity of each hydrate to a clean dry beaker. And the key thing is that each salt should be placed in a separate beaker. Four, we'll be using tongs to place each beaker on a separate hot plate. So we're running three separate experiments. We're going to take our tongs and wire gauze. We're going to place our tongs and wire gauze by each hot plate. And now each hydrated salt will be heated by turning the heating knob on the hot plate halfway. So we'll be starting the heating process. And then, if very important, if you hear any popping or crackling sounds during the heating, make sure to use your tongs to transfer the beaker to the wire gauze to cool down. That means popping that could indicate that the water have already evaporated and the salt is beginning to jump out of the beaker. We don't want that. So if the sound stops, put the beaker back on the hot plate. Never touch the hot plate with your bare hands. Always use tongs. Very important. You could get burned. At the very end. We're going to record our observation of the hydrated salt after heating, and after 30 minutes of heating, you can turn off the hot plate completely and transfer the beaker to cool down on a wire gauze. All right, and once the beakers reach room temperature, we can dispose the salts in the proper waste container. So here are the three chemicals that we will be using. The one that you see on the left is the cobalt 2 sulfate heptahydrate. Note the color right here. Write the color before we start the heating process. This maybe looks orangish, bronzish color right here. And notice we have the scopula. We'll be using the scopula that I'm pointing to in order to put some of the cobalt 2 sulfate heptahydrate into our beaker, and we're going to be heating it up. The middle compound that we'll be using here is nickel 2 sulfate hexahydrate. Notice it has a beautiful greenish color. This is the color before we start the reaction. Again, make sure you're writing down the color, write down your responses in full sentences. And the last but not least, we have the copper 2 sulfate pentahydrate with its characteristic beautiful blue color. Now, let's see what's going to happen in our experiment. Now, the first thing we are going to do now is that we are going to make sure that you're getting the chemical, the chemical that you want. Make sure it's labeled properly. Proper labeling is critical. So you're going to take that much of your hydrate. You're going to now place it carefully. Make sure you're not dropping any into the beaker. Note the properties. It's a solid. It's a solid. It's not powdery. It's a bit grainy. And now we are going to cover it up. All right. Note the color now. Look at what's happening as we're heating it up. See, it's fogging up a little bit. Look at the color now. Is it bronzish anymore? It's changing. Now it looks a bit pinkish. See, and the bronze color is disappearing. And notice the water. So the reason why we're trapping it is to see the water vapor condense, which proves that there is water inside. So notice there is no water. It's a solid. We have solid that we're putting in the beaker. This is now the nickel 2 sulfate hexahydrate. We're going to cover it up. This proves that we have water inside, because the water is going to start condensing on the piece of glass. This is called the watch glass. All right, we're heating it up. Notice what happens to the beautiful. Okay, we're gonna go back and look at the water vapor. And look, so this experiment, you got to shake it up a little bit to increase the surface area to make sure the other solid particles get a chance to heat up. You want even heating. Let's go back and see what happens to the green color. Notice the green color, it looks like it's disappearing and it's turning into a lighter green. Now we're going to go to the copper 2 sulfate pentahydrate with its beautiful blue color. So the reason for the color blue is that water is trapped inside the hydrate. So we're going to add this much. We're going to cover it up. Yes. We're gonna just make sure to shake it in order for even heating. You want even heating as much as possible. Placing it on the hot plate. Now we're going to bring the watch glass, cover it up to see if there is really water trapped inside. Yes, and again, we're checking to hear for any popping sounds. If we see any popping sounds, we got to take it off the hot plate. Good, see that? So it's turning from green to a lighter green, and this is turning to pinkish color. See, the water is condensing at the top. Now green became a lighter green a little bit, and water is condensing at the top. See that? The experiment is almost over. And now we see the blue is disappearing and it's becoming less blue, obviously, more grayish, you can see. So again, one more time, the before and after. And here we have the second chemical before and after. Yes, and then we have, you can see the color, it's disappearing, and here's the before and after. This is all right. Now let's give you the colors again one more time, the before and after. So here is the first experiment. This is the color before, and this is the color after. This is the second experiment. Notice the green color, and this is the color after. It's lighter green, it's turning a bit yellowish. And then the third experiment, the third hot plate, blue is the original color, and you can see it's less blue. It's even turning a bit grayish. So make sure to record all your observations before and after in our data sheet. So again, let's look at the first one. This is the copper 2 sulfate heptahydrate. This is the cobalt 2 sulfate heptahydrate. Note the color before and after. So this is an image up close of the cobalt system. This is before, and the right side is after. The next up, we have the nickel 2 sulfate hexahydrate. This is the color before, and this is the color after. Just write the color that you see. And the last system is the copper 2 sulfate pentahydrate. This is the color before on the left on the watch glass, and the color after is on the right side, the beaker with the watch glass that's sitting on top of the wire gauze. So this is the wire gauze right here. All right, very important. The last thing you want to do after you write down all your observations is that in one or more paragraphs, make sure to summarize the results of this experiment. You want to write in full sentences. Avoid using bullet points or sentence fragments. Now, the next steps are very important. Make sure to describe any trends or patterns you observed. Make an effort to support your statements by referring to the theory in the pre-lab discussion. So one thing you want to mention the definitions of hydrate. What's a hydrate? Anhydrous salts. What are anhydrous salts? Make sure we talked about ions. Mentioned ions. We talked about salts. There's a lot of things you can mention in your report to receive full credit. For instance, you also want to add, how can you tell when the removal of water from a hydrated salt has occurred? how would you know? So you can talk about the watch glass and how water is condensing. You can talk about the color change. You can refer back and mention specific examples from our experiment. Make sure you're supporting your statements with examples from the data that we went over, that we covered, from the data that was covered. So this is experiment number 6. Thank you for watching the video. You are now expected to complete the following tasks. 1, watch the video, which you already did if you reached the end of the video. 2, you want to complete the quiz that's based on the experimental video. You're going to find the link on Brightspace. And last but not least, submit the lab report using the given template based on the experimental video. If you have any questions, let me know. Thank you for listening, and I'll see you soon.